Good evening. Before I start, anyone has any questions? So you have more than a week to study for the final. Also for some of you to make up your homework. Because our final is on May 24th as posted on Blackboard. I still don't have the room yet. As soon as I get the room, I'll post it on Blackboard. So today is our last class, our last meet. Okay, I hope all of you studied the guide for final. Anyone has any questions? Anyone has any questions from homework or from this study guide? Yeah, today's our last class, our last meet. Next week is called Readings Week. Readings Week means you study for your final. No, next week is called Readings Week. Right? Fine, because CUNY always leave you 1 week for study for your final. You still then follow the Readings Week is a finals week. Yeah, Readings Week means you study for your final. That's like a term for CUNY. Would there be a curve? What do you mean? What do you mean by curve? Curve for final. Oh, it depends. It depends on how well the whole classes do. For now, I cannot tell yet. Yeah, some of you homework already get 100% right. But, you know, for the purpose of taking final, you still have to do all the homework, right? Because the homework will appear, the questions will appear on your final exam. Let me check CUNY calendar. The final is still 40% of our grades, right? The final, right. will follow our syllabus, but let's see how well the whole class is doing. All right, because you have enough time to study. Hopefully everybody can do better for the final. Yes, I still accept homework until May 24th. May 24th will be last day, okay, for you submitting your homework. Okay, any other questions? I don't have a format of final yet, but you know, I would assume so. It has to cover the basics, right? But for this review sheet is a kind of a challenge because they put everything together, because to make you to think the concepts as a whole. So make it right, study your homework. Make sure you know how to handle the homework questions. Quickly go over 196 on the homework. Yes. No calculators be provided. College don't provide you anything. You have to prepare only scientific calculators, no graphing calculator. Only scientific calculators are allowed. College do not, unless you are in some special programs. I think like SEEK program and some other programs that offer you some utensils. But for normal college classes, nothing to be offered. Okay, let's go over 196. Homework. Let me open it first. Oh no, I don't want to show this one. You get another one. Region enclosed by the inner loop of R equals 3 minus 4 cosine theta. Well, we just follow. Okay, so we need to find the area, right? So this says determine the definite integral that represents the area, right? We just have to find the area enclosed by this. Right? Sorry, I'm feeling horrible here. 3 minus 4 cosine theta. I posted some stuff for you guys to see it. If we graph this one, if we graph this 3 minus 4 cosine theta, I upload a file for you to read. It's about polar curves, right? To see the patterns of polar curves. Remember, forget about these three, right? If r equals -4 cosine theta, we have a circle on the left-hand side. So just imagine we still have this, you know, r-axis, and we make a vertical axis. Remember, -4 cosine theta is on the left-hand side. It's a circle. It's a radius 4 circle on the left-hand side, right? If the sine theta is up and down circles, if the cosine is left and right, it depends on the coefficient, the number before sine or cosine. So -4 cosine theta, we have a circle on the left-hand side. Left-hand side is a vertical line. Then add 3 to it, 3 minus that, 3 minus 4 cosine theta. We just have an inner loop, right? We have a small inner loop. Let's see, I should show you the graphs. Let me show you the graph. So you still have time to study, so make sure you use this. This is decimals, right? Polar graphing, you know, graphing polar curves by decimals. 3 minus 4 cosine theta. You see, if I delete 3, you see -4 cosine theta, it's just a circle, you know, passing the center, right, on the left-hand side. Then if I add 3, so I get this inner loop. So what this question asks is find the inner loop, the area for the inner loop. So we need to find the area of this guy, right? Excuse me. Oh, James, you're typing. Try to type in the. Okay, let me read James' comments. Yes, James, right. Answer to your last question, yes. This should be right. Yeah, try to type the question in everyone so I could see everyone's comments. If you text me only to me, let me see. Okay, thank you. All right, so now let's see this one. So we have to find the area of this inner loop, the smaller one. Let's think about how this graph is graphed. This one just doesn't show me. Well, from 0, right, 0 degree, just follow my cursor. 0 degree, go, go, go. Yeah, keeps going. Right, up to here, 180 degree, right? Or let's just use pi, use radian, because everything is in radian. And so this value, what is this value? This value is -7. You can also see the value, because -4 cosine pi, that's -1. -1, -4, that's +4, right? So 4 plus 3, that's 7. So we get this. So this point is on the circle with radius of 7. So keep going up to here. What's the radian? We have and my cursor had done 2 pi. Do you see that? So from here, that's from 0 angle, 0 radian, go. So we have run 2 pi radian. Then it keeps going from 2 pi to 4 pi. You see that? So for this question, it's all about to get the upper limit and the lower limit right. So the rest is easy. Does it help? Let me see who asked it. Paul. Paul, does it help you? So the only difficult thing is to set the lower limit and the upper limit right. The rest just follow the, what do you call it? Follow the formula, right? Square root of r squared plus r prime squared, right? Find the r, so r squared, r is right there. R prime, what's r prime? R prime is -4, well, cosine is, derivative of cosine is negative sine. So negative, negative, positive. So r prime is 4 cosine, 4 sine theta, right? Then square that, we get 16 sine square. Then r square, so just, do the r square. 3 minus 4 cosine square, we just square that. Oh, you cannot see my cursor? All right, but anyway, do you see the, okay, to graph this whole thing, right? To graph this whole thing, the degree has gone 4 pi. So the one period is 4 pi. The inner loop is going from 2 pi to 4 pi. The outer loop is from 0 to 2 pi. Does it make sense? Okay, all right. So the rest just follow the formula. Okay, any other questions from homework? For this one, you just have to determine a definite integral. You don't really have to calculate, all right? For 96, it would be very difficult to calculate. We could do 0 to pi and double it as well if we wanted. No, try not to do that. Try not to do that because that will confuse you. The answer, right? Okay, 0 to pi, you only run pi, right? 2 pi to 4 pi, you have run 2 pi. But 0 to 2 pi and 2 pi to 4 pi, would give you the same answer. But however, train your brain, with the right thing, because the outer loop is from 0 to 2 pi, the inner loop is from 2 pi to 4 pi. All right, other questions? Okay, anyone has any other questions? What about the studying guide? Anyone has questions with the study guide for final? Really, no one has any questions? You are all ready for, everybody's ready for final? Sorry, I'll be right back. Let me get some water. Can you walk through all the questions? Can you walk through all the questions so we can check our answers? I haven't had time to go through it yet. Plan on studying in the next 2 weeks. I see. Okay, let's do that. Let's go through them. But probably I won't do it in detail. Just to give you some hints. Let's see the question 1 type. We're given f5 equals 25, f of 0 equals 8. So we're given 2 points. Then we're given integral f of x. So the area under f of x from 0 to 5, that's 3. x of x, and the x of x from 0 to 5, that's 10. So we want to evaluate this. Well, what's the hint here? Integration by parts, right? Let me type in the chat. So remember uv. So my u is a function of x, my v is a function of x. Actually, let me use fg, because here we have f, right? Which is considered. So remember f times g product. You know, if we have product of two functions, how to take derivative? That's f prime times g plus fg prime. We can take integrals on both sides, right? So when we take an integral on both sides, we have fg. I'm typing in the chat. So integral of fg derivative, that's just fg. Then on the other side, we see, how do I write this? So I'm going to use, okay, I'm going to use capital letter S as integral, okay? So integral fg prime equals to integral of f prime g plus integral of fg prime. So what's that? So this, in this case, we see we have integral f prime g, right? F prime g. The integral of f prime g is equals to integral of fg prime. Integral of fg prime, that's fg. Or in the integral, in the book, we call uv, right? We call uv. So that is fg minus, so integral f prime of g just equals fg minus integral fg prime. So what's our g in this case? So g in this function is just x squared plus 3x plus 7. So we need to find g prime. G prime is 2x plus 3, right? Then we just, so we need to find f prime g. That equals to fg. Well, f we know, so just f times g, right? What's our f? F times g. Let me just do the f times g equals to f times f multiply, what's g? G is 2x plus 3. Where fg equals to 2x f of x plus 3 f of x. Right? So we just, you know, all the information are given in the question. So basically just integration by parts. Integration by parts comes from different product rule. Okay, product rule. Any questions for this first one? All right, let's keep going. Second one, so we don't have to evaluate. Just, oh, what did I talk about? What did I see for the first one? I said integration by parts? No. Did I? Yeah. Okay, so this is by partial fractions, right? So question 2, we needed to do by partial integration, partial fractions. Remember partial fractions? We write down a times. So we're going to split into, well, let me just write down this. We're going to split into a over x plus 3 plus b over 9x squared plus 4. 9x squared plus 4 cannot be factored. Plus 4. Right? Equals to 1 over x plus 3 times 9x squared plus 4. But because one factor 9x squared, it has x squared is quadratic, so the numerator needs to be linear. So bx plus c. You can type in the chat to see if this makes sense. So this is partial fractions. So we set up as a divided by x plus 3, because x plus 3 is one of the factors in the denominator. Then plus bx plus c over 9x squared plus 4. Why has to be bx plus c? Because the denominator is a square, it's quadratic. It's quadratic, so the numerator can be linear, can has x term in it. So that's why it's bx plus c over that, and equals to 1 over the whole thing. So then what do? We have a times 9x squared plus 4 plus bx plus c multiplied by x plus 3 equals to 1, right? Because we make a common denominator on both sides, which is x plus 3, x plus 3 times 9x squared plus 4. So for the first fraction, a over x plus 3, we'll have to multiply 9x squared plus 4. So we have a times 9x squared plus 4 plus bx plus c. Then we just simplify that, right? So we have 9a, actually 9a x squared plus bx squared plus bx 3bx plus c plus 3. So actually this one we can do equal to 0. We should get 3 equations, right? So that's x term. That's x squared term. Then for x term, we only have 3bx plus cx. That also equals 0, because on the right-hand side, we only have 1. Excuse me. The right-hand side, we don't have x squared. We don't have x. That means x squared term is 0. Thank you. And the x term is 0. Then for constant, we have 4a plus 3c. That equals 1. So we have 3 system of equations. We just need to solve this system of equations. We have a, b, c, 3 variables. Right? We just have to solve a, b, c. Okay, so I assume you know how to solve system of equations. All right, you can find a, b, c. Any questions on question 2? Anyone has any question on question 2? Just go through partial fractions, right? So in the end, you get a, b, c, 3 values. you just substitute into a over x plus 3 and bx plus c over 9x squared plus 4. Let's see question 3. Should I go to question 3? Okay, question 3. Question 3. Okay, we want to use trig substitution. So this one we need to go to the whiteboard. But we won't be able, they should delete x plus 3 here. Because we won't be able to do with 2 factors. I would assume the question without x plus 3 in the denominator. All right, let's go to whiteboard. For trig substitution, so we have 1 over 9x squared plus 4, right? So the integrand, we have this. We have 1 over 9x squared plus 4. So what do? We want to draw a triangle. We want to draw a triangle, especially, a right triangle. Okay, then we think this way. Then we think, okay, 9x squared plus 4. All right, I'm going to think this side as 3x, and then this side as 2. And then the hypotenuse would be square root of 9x squared plus 4, isn't it? So that's how we do trig substitution. So make this triangle, all right? Make this triangle 3x squared will get 9x squared. This side is 2, so 2 squared is 4. So the hypotenuse is 9x squared plus 4. Okay. Then we want to work with this angle. Oops. All right, we call this angle maybe theta. All right. Then we can see, okay, what's the sine theta? Well, actually, let's do cosine theta because our integrand is 1 over 9x squared plus 4, right? We don't want to use, if our integrand is 3x, has x in it, has x in the numerator, we would do sine theta, right? We would do sine theta equals to 3x over that. But here we see that's 1, the numerator is 1, so we do 2, we do cosine. So we do, oops. So we want to substitute with cosine theta. Let me use b equals to 2 over hold on a second. Hold on a second. We don't have a square root. I'm doing something wrong. We don't have a square root. We just have 9x squared plus 4. 9x squared plus 4. Okay. Forget about this. Okay, if we do, but let me finish this case. If we do have 1 over square root, if this is indeed square root of 9x squared, okay, we should draw this picture. We should draw this picture. All right. But for that case, we don't have that. We don't have that. We're going to use another one. Okay. If we do have 1 over square root of 9x squared plus 4, we would draw this picture. Then we see cosine theta equals to 2 over the denominator over the square root of that, blah, blah, blah. Then we just divide by 2 on both sides, right? That just becomes 1 over that. Then we substitute the whole thing with cosine d over 2, half of cosine d. But now we don't have, we have to use the formula. The formula, we have a squared plus b squared, and in the denominator, I personally don't remember that. Excuse me. Let me find. So we split. Yeah, because we don't have a square root. I remember that's another formula. I just couldn't remember it at this moment. With the square root one, it's easier. You draw the picture of a triangle, then you figure out from there. Without, I remember it's a tangent. It's oh, I'm being silly. I am being silly. Without it, what do we get? We just square both sides, right? So there's 1 over this. Then we just square both sides. We still draw this picture, right? Because for the question, we don't have this square root. We just have 1 over. Well, the other side is easy, right? Then we have a over x plus 3. So once we have partial fractions, this part will be easy, right? But this part we have actually we have a bx plus c, right? So we can split into bx over this plus c over this. Nine x squared plus 4. Right. So you will find out ABC. Okay, I'm not going to do that. You solve the system of equations, you find ABC 3 values. Once you have ABC 3 values, you use trig substitution, right? This one is easy. This one you don't use trig. This one just a times ln the log, right? Absolute value of x plus 3. This part you don't need trig substitutions. So this is the anti-differentiation for the first one. But for the second one, you see you have bx. So you want to use sine theta, right? Because sine theta, in this case, I'm going to use sine b. Sine theta equals 3x divided by square root of that. Oh, hold on. Excuse me. Square root of that. Then cosine theta equals to, so this one is c over this, right? Cosine theta, you want to do equals to 2 over that. Then you square both sides because you want to get 9x squared plus 4 because no square root underneath. Right. So for trig substitution, you just draw the picture. You just draw the triangle, right triangle. You do the substitution. You only have to set up. You don't have to solve it. Okay, anyone has any questions on that? Should I go question 4? Does anyone still have question on 3? All right. So if no one sees anything, I'm just assuming there's no. Let's see 4. We have an ellipse. Ellipse, we have a standard form. Let me write this down. So we have x squared plus 12x. Actually, we didn't talk about ellipse. Remember the parametric equations. Parametric equations for ellipse. We talked about parametric equations for circle. For ellipse, it's only a little bit different. So x squared plus 12x plus 4y squared plus 20y equals to 400. So what do we need to do? We need to set up. We don't need to evaluate an expression to determine the distance. All right, the distance the asteroid travels in one orbit. Okay, so we need to be able to write this ellipse in parametric equations. Then we use the parametric equations find the length of the curve. Remember the formula? So we learned for find area. Remember length. The length is square root. Oh, hold on, that's area. Arc length. Oh, really? I even forgot. Okay, arc length. What's the difference? What about the area? Hold on a second. Oh, hold on. Okay, I think I gave you wrong information before. The area of the region bounded by polar curve is a half of integration with lower limit, upper limit, r squared d theta. Has nothing to do with r prime. Square root of r squared plus r prime, that's the formula for the arc length. All right, so let's go to the whiteboard for this question. So let's just remember this. Area is this. It's a half of lower limit, upper limit, half r squared d theta, okay? The previous one, what do we have? We want to find the inner one. That's a half. The 196, the homework 196. Lower limit 2 pi, upper limit 4 pi, just r squared. Well, it's 3 minus 4 cosine theta squared. Then d theta. Right. Okay, for the arc length, arc length, lower limit, upper limit, square root of r squared plus r prime squared, or dr d theta. Okay. Oh, hold on, what I'm talking about? Because this is right, but we're not going to use this one for question 4, all right? But this just remind us, right? If we want to find the arc length of a polar curve, that's this formula. If we want to find the area under a polar curve, that's this one. That's this one. So those two. All right. I think before I was talking about square root of r squared plus r prime squared. No, finding area is the first one. It's this one. Half of r squared d theta. Find the arc length is this one. But now we want, for this question, for the ellipse, we want to use parametric equations to find the arc length, which is a little bit, it's very similar to this one, but a little bit different. We have a parametric equation. It's a little bit different, right? We still have lower limit, upper limit. Let's use AB. We'll have a square root x prime square. Well, remember that's x in terms of t, right? Parametric equation, x is a function of t, y is a function of t. So plus y prime of t dt. This is also square. Then square root dt, right? We want to use this equation. So what's the parametric equation for ellipse? It's this. For ellipse, parametric equation is x of t equals a cosine t, y of t equals to b sine of t. Okay, a, b, if a equals b, we get a circle. If a, b are different, we get an ellipse, right? So the idea, so a circle is just a special ellipse, right? Yeah. So the rest is just the same. So in this one, what do we have? We have here, we have x squared plus 12x plus 4y squared plus 20y equals to 400. So we need to find an a, we need to find a b from here. So how do we find an a? How do we find a b? We need completing squares, right? So x squared plus 12x, 12 divided by 2 is 6. So we want to add 6 squared. 6 squared is 36. Then for the second one, we want to, for y term, we want to factor out y, factor out 4, so y squared. 20 divided by 4, we have 5. So 5y. 5 divided by 2, we want to add 5 over 2 squared, which is 25 over 4, equals to 400. Whatever we add on the left-hand side, we're going to add on the right-hand side, right, to make the equation still equation. So what did I do? I added 36 here. Oh, actually, I have to do 4 times 24. I add 36 here. but this 24, so this actually just 25, right? You see this 4 times 25 over 4, just 25. So I added 25 here, I have to add 25 on the right hand side. Now I simplify, so now I can make square term, right? So x squared plus 12x plus 36, that's x plus 6 squared. Then plus 4 times y plus 5 over 2, 5 over 2 squared. That equals to 36 plus 25, that's 61. So 461. Then I have to divide it by both sides. Remember, how do we figure out A and B by the conic section? We need to divide it by, we need to make the right hand side 1. We didn't really talk about much about this. So we divided every one by 461. So now the equation becomes x plus 6 squared divided by 461 plus y plus 5 over 2 squared divided by 461 divided by 4 equals to 1. So this is a standard form for ellipse. So this is saying this ellipse is centered at -6, -5 over 2. And with A is important for us. So with A equals to square root of 461. And B equals to square root of 461 divided by square root of 4, which is just 2. So then we just substitute in here. So x, so that means x of t equals to square root, oh, I hope they made a better number, square root of 461 cosine t, and then y of t equals to square root of 461 divided by 2 sine t. Then we want to use this equation, this formula. So we need to find x prime, y prime. Then we just substitute in it. We don't have to evaluate. We just set up. Then now we'll have one more thing, A and B. Well, when the ellipse, right, run a full resolution, that's from 0 to 2 pi. Because it's on Cartesian coordinates also, right? So from 0, so lower limit is 0, upper limit is 2 pi. Square root of x prime square plus y prime square. X prime square, we just get it from here, right? So x prime of t would be negative square root of 461 sine t, right? Because the derivative of cosine is negative sine. And then y prime, just square root of 461 divided by 2 cosine t. Because the derivative of sine t, just cosine t. Then we just substitute. We don't have to evaluate. All right, just set up. Anyone has any questions? Does the ellipse being off center change anything? No, it does not. It does not. Yeah. Because you can always translate, right? You can always translate because it's the same ellipse. A doesn't change, B doesn't change, only the center changes. But the center changes doesn't change the, the arc length. You're welcome. Any other questions? We just have to get A and B from here. All right. So parametric equation for ellipse is x equals A cosine t, y equals b sine t. If A equals b, that's a circle. It does not equal to b, we get an ellipse. So how do we figure out A and B? We have to complete in squares, write it in the standard form. Standard form is x minus h squared divided by a squared plus y minus k squared divided by b squared. Okay, next question. Okay, let's see this one. We have this region PQR made by three functions. We have f of x, g of x, h of x. And the point P, R, and Q are given. So x value, so the points given, the x value is important for us because we need a lower limit, upper limit for x. Let's see, what do we have to do? So suppose this region is to be revolved around x-axis to produce a solid of revolution. Set up two ways, don't integrate. Oh, that's nice. You know, we don't have to integrate, we just need to set up. You have learned three different methods of using integration to find the volumes of solids of a revolution: shells, disks, and washers. Which of these methods is not suitable for computing the volume of the solid of revolution? Explain why. Write down integral expression corresponding to the computer in each of the two methods. Suppose f and g are linear functions, but h for some values a and b. Time to find a and b. Then the values are relevant for this question. Which of the two integrals are? Oh, okay. Yeah, I think this study guide is just just want you to think about what you have learned. Well, let's see this one. So imagine this revolve with x-axis. So we will get a 3D objects, right? So imagine this one is, we have another piece. We could draw another piece over here, reflected with over x-axis, right? Then the section of this just perfect circles, right? Just perfect circles. So the easiest way would be disk method, right? Disk method and the washer method. And if we use a shell method, it'll be difficult, right? Because why? You see, this region is made by three functions, not two functions. Okay. If you really want to use shell method, well, I don't know. Disk method is the easiest one, right? What washer method? Washer method, you just use the outside, subtract the inside. Right? Let's use disk method. It's the easiest one. So we want to set up two integrals from point P to point R. So point P, the lower limit at point P, x value is 1. At R, x value is 2. So we set the first integral from 1 to 2. Yeah, 1 to 2. Well, what's the washer method? What's the radius? Oh, excuse me. We could use washer method, we could use disk method. Okay, washer method and disk method are very clear, very similar. Right? You just combine the two integrals together. Or let's use disk method. So disk method is saying, okay, we find the volume with this one. I don't know if you can see my cursor, with the g of x. Okay. So g of x, when we revolve this region with x-axis, so see the line of g of x. G of x, of course, is a constant function, right? It's a straight line. So the volume would be a cylinder, right? The volume would be a cylinder. So what do we have to do? We just find the area of the section, pi r square, right? Pi r square, then set up the limit. So we integrate, if from P to Q, we just find integration, lower limit is 1, upper limit up to Q, Q x value is A, right? So set up one integral. I'm going to write down here. If you still have questions, I'm going to write on the whiteboard, all right? So first, use the disk method. So find the volume made with g of x. So the lower limit is 1, upper limit is 8. So pi we put outside, pi is constant. So we need just pi r squared, right? Pi r squared dx. Well, what's r squared? What's r? R is just function g, right? So basically g of x squared, right? Then this is the cylinder. Now subtract. So we need to subtract two things because the inner one is made by f of x and h of x. So we need to subtract two integrals. One integral is for f, right? F. So f for f goes from p to r. So that's from 1 to 2. Well, we just do f of x squared, right? dx. And subtract another one that goes from 2 to 8. That's which function? That's h, right? So the r is h. So the radius h, so h squared dx. So this is one way, disk method, or we can use washer method. For washer method, we have to consider what's the r. Do we need to use two methods? So we need to set up two methods, right? Okay, anyone has any questions for disk method? Washer method is not too much different from disk, right? We just have to subtract we just have to consider radius. So for the radius from 1 to 2, what's the radius? The radius is just g minus f, right? And for from 2 to 8, just g minus h, right? Anyone has any questions for this? All right. Okay, let's keep going then. L'Hopital's rule. Suppose f and g have the following values: f of 10 equals 1, f prime of 10 equals negative 6, g of 10 equals 1, g prime of 10 equals 6. Okay, so at 10, f and g intersect. But the derivative is 1 is negative 6, 1 is 6. So 1 decreases, 1 increases. Assume all functions are continuous. Find the following. So limit x approaches 10, f of x squared minus 1 divided by ln g of x. Well, so g of 10 is 1. ln 1 is 0. 0 in the denominator. Well, f of 10 is 1. 1 minus 1 is 0. 0 divided by 0 is an indeterminate form. With the indeterminate form, we can use L'Hopital's rules. L'Hopital's rules is saying take a limit of the quotient equals to limit of the quotient of their derivatives respectively. So we take the derivatives of numerator. We get 2 f of x, f prime of x. Right? I'm going to write in the chat. So we have 0 divided by 0 indeterminate form. We can apply L'Hopital's rule. So we take derivatives. Right? So we still have a limit x approaches 10. Derivative of the numerator is 2 f of x, f prime of x, right? Chain rule, by chain rule. Then divided by denominator, derivative of denominator ln g of x is 1 over g of x, right? Derivative of ln of x is just 1 over x. Then multiply by g prime of x. So basically, so we have this, I type in the chat. So we have 2 f of x, f prime of x divided by g prime of x divided by g of x. So that just becomes 2 f of x times f prime of x times g of x divided by g prime of x, right? Then we limit approach to 10. Now we can substitute in the values because we won't get a 0 in the denominator anymore because g prime of 10 is just 6. So we get 2. Okay, I don't want to write it. So f of 10 equals 1. 2 times 1 is 2. F prime equals -6. So that's negative. So 2 times -6. Well, g prime of 10 equals 6. So -6 divided by 6, that's -1. So we just get -2, right? So the first one should be -2. All right, so the second one, the bottom one is f of x minus 1 squared divided by g of x minus 1 squared. If we plug in, no, we cannot. So we get a 0 divided by 0 again, right? 0 divided by 0 again, we can use L'Hopital's rule. L'Hopital's rule give us 2 f of x minus 1. And this is times f prime of f of x divided by 2 of g of x. I'm going to ignore the x because it's too much. So we're only going to write 2 of f minus 1 times f prime times 2 g minus 1 times g prime, right? L'Hopital's rule. 2 divided by 2 simplified f minus 1 f prime g minus 1. Oh, we still get a 0 by divided by 0. So we have to apply L'Hopital's rule again. Because f of 10 is 1, 1 minus 1 is 0. G of 10 is 1, 1 minus 1 is 0. So we have 0 in the denominator, 0 in the numerator again. Apply L'Hopital's rule again. So we simplify, we have f minus 1. Okay, so f minus 1 times f prime divided by g minus 1 times g prime. Now actually we can split. Remember product. Remember limit of product equals the product of limit. We can split about taking the limit f minus 1. Otherwise we have to apply a product rule. G minus 1, and also we get into f double primes, right? So split as this, split as f prime divided by g prime. And when you take the final, always try find an easy way out. Then the first part, f minus 1 divided by g minus 1, if we plug in the 10, we still get 0 divided by 0 in determinant form. So, right, we just take a derivative again. So get f prime, g prime, right? Okay, that's easy. So this part is easy. Okay, anyone has any questions for this? I think none of you should have questions on this. So this one, looks a lot of stuff, but it's easy. Right? You get it in indeterminate form. Sometimes 0 divided by 0, sometimes infinity divided by infinity, stuff like that, or 0 times infinity. So you apply L'Hopital's rule. If you know one time doesn't work, you keep taking, you know, you keep applying L'Hopital's rules. All right, let's see this question. The graph of f and its tangent line at x equals 0 is shown. A second point on the tangent line is also marked. Assume f prime x is continuous. Find limit x approaches 0, f of x divided by x. Find the limit x approaches 0, f of x divided by 3 e to the x minus 3. Well, x approaches 0, we have denominator 0. F of x is also 0. We have 0 over 0 indeterminate form. Just apply L'Hopital's rule, right? L'Hopital's rule, derivative of the numerator is just f prime of x. Derivative of x is just 1. So that just equals to f prime of 0. Well, f prime of 0, we don't know, but we know it's continuous. You know, it's continuous for all x. Just so the first one just equals to f prime of x. The second one, if we plug into 0, we get 0 in the denominator, the 0 in the numerator, so we still have 0 divided by 0. So apply L'Hopital's rule again, f prime of x, f prime of 0 divided by 3 e to the z. Now 3 e to the x is 0, just have 3. So this is 1/3 of f prime of 0, right? Oh, I think everybody can do this. Okay, anyone has a question for this? Question 2? You showed it, yes. Okay, let's see this question. All right. Suppose f of a equals 6, f prime of a equals 4. We want to take limit x approaches a for this first one. This one, let's see. X squared minus 4x minus 32 can be factored, right? So x squared minus 4x minus 32 can be factored as x minus a times x plus 4. Then, of course, if we plug in a, we get a 0 in the denominator, so we cannot plug in. So we cannot plug in. So we just apply L'Hopital's rule. So numerator also. Numerator will have e to the f of x. Well, f of x is 6. F of a is 6. So e to the 6 minus e to the 6 is 0. 0 divided by 0. Again, indeterminate forms. Indeterminate forms, we apply L'Hopital's rules. So we take a derivative of the numerator. We get e to the f of x multiplied by f prime of x. Denominator, we get 2x minus 4. Now, can we substitute a in? Yes. So denominator will be 2 times a minus 4, which is 12. The numerator will have e to the 6. E to the 6 times f prime, which is f prime of a, which is 4, divided by 12. So we get a 1/3 of e to the 6. Right? So the first one, so this part we get a 1/3 of e to the 6 just by applying L'Hopital's rule. That's it. Let's see the bottom one. Bottom one, x approaches a. Well, let's check the denominator. Denominator, we have x plus a squared. Right? So a is in the domain of this function. So we don't have to do anything. Just substitute 8 into this function. So we have e to the f of a, which is 6. 6 minus 6 is with e to the 0. Minus f of a, which is 6, plus 5. That's the numerator. So numerator we get, numerator we get 0. Because e to the 0 is 1. 1 plus 5 is 6. 6 minus 6 is 0. We don't have to calculate the denominator. So this bottom one, we just get 0. We don't have to apply L'Hopital's rule, right? Because it's not in the indeterminate form. the denominator can be factored as x plus a squared. So we can just plug in this 8, right? Okay, anyone has any questions for H3? So the first one, 8, is not in the domain of the function, right? Because the denominator can be factored. One of the factors is x minus 8. If we plug in a into it, we get 0 in the denominator. So we check 0 in the numerator, 0 in the denominator. If we plug in a, that's the indeterminate form. So we apply L'Hopital's rule. But the second one, 8, is in the domain of the function. If a is in the domain of the function, we just plug in. So that a is in the domain of the function is equal to function value. We just plug in. Okay, let's keep going. Improper integrals. Assume f of x continuous and positive everywhere, and that f of x converges. Find the following, assuming exists limit x approaching infinity, f of x. Well, if this one converges, that means after certain x, it has to go to 0, right? It cannot be positive everywhere. This is not true. I don't agree with this question actually. Assume f of x is continuous good, and the positive cannot be positive. If f of x is positive, let's see. Okay, it could be positive. It could be very small value. This is 1 divided by 1 gillion. All right. So basically, so what is this? This goes to 0, right? So limit of it goes to 0, because for any improper integral to converge, right? The terms up to a certain point of x, the limit of the function has to go to 0. And what's the derivative? Because that means f of x cannot be increasing, right? F of x cannot go bigger and bigger. It has to go smaller. So that means this one, so b less than or equal to 0. It can be a negative value. That means function value decreases very fast, or just 0, or just doesn't change, right? So use this to decide on the convergence or divergence of the following. Well, of course, converges, right? The first one, because it's smaller than this one. This one starts from 1. This one starts from 10. This one is smaller. The big one converges, and this one converges, right? And this one just horizontal shifting. Remember that? The function, right? Just horizontal shifting. But that one converges, the shifting converges as well. Well, this one, consider this one, right? This one we don't know, right? Because this is 3x. This one actually diverges, because when x approaches infinity, 3x diverges, right? So this one diverges. F of x divided by x. F of x divided by x. Right, if x is a very small value. Hold on. X is greater than 1. Okay, this one converges as well. Because this one is smaller than this one also. Because x is greater than 1. X is greater than or equal to 1. Yeah, so this one converges. F of x squared. F of x squared. This one should also converges. This one should also converges. This one should also converges because sine x is bounded between -1 and 1, so it's bounded. Right? So the only one not diverges is this one. All right. Okay, anyone has any questions? Polar coordinates. Okay, so we have to match the graph. So let's think about this graph. So the upper graph is the sine of 2 pi, isn't it? We don't really care about the amplitude because it doesn't even see anything. But we see this sine graph, right? And with one period is pi, so that has to have a 2 factor in front of the angle. So this is sine 2 pi graph with in Cartesian coordinates. In polar, that's this one. That's this one. Because why is this one? Look at this one. Why is this one not this one? Because sine of 4 pi, sine of pi over 4 multiply 2, that's pi over 2. So we reach this biggest value 1. And up to pi over 2, 2 times pi over 2, that's pi. Sine pi equals 0, so come back to the origin. Right? So this one should be cosine of 2 pi graph. You just could try two numbers. All right, you see this one, why is cosine? Cosine 2 theta. Cosine 0 equals to 1. Right, you see this point. And 2 pi, cosine 2 times 2 pi, 2 times 2 pi, excuse me, 2 times pi over 2, that's pi. Cosine pi is -1, also reaches 1, even it's a -1, because in polar, we just consider that's on a circle with radius 1. So it should be the middle one. All right, should be the middle one. You just check 2 values. Well, it's not of this, right? It's not of the first one. What's the first one? The first one should be 2 sine theta, right? Or a sine theta, because we really don't know the value. We really don't know the value from this amplitude. So it's just a sine theta, right? Whatever this. So this is 2a. From the origin to this top point, that's 2a. Well, we should think about it too, because this period is just 2 pi. It's just pi. So this should be 2 sine a. All right. So 2 sine a here, -2 sine a here, 2 cosine a here, -2 cosine a here. So this is sine 2 theta. This is cosine 2 theta. I posted the article, okay? I posted one file in the course documents. So that gives you a pattern about those polar curves. Let's see this one. Suppose a greater than 0, so r equals a sine 2 theta. So which one? Again, that's this one, right? That's this one. Because we use the same method to check. Because sine 2 theta. If the a sine theta, we get this one, a positive. And this is Cartesian plane, right? We won't be able to get this graph. And this is for cosine, this is for sine. The graph shows r equals to f theta, g theta, so we have 2 theta functions. So f solid, r is dashed. Points have coordinates a, 4, So A is a point on a circle with radius of 4. Angle is pi over 2. B is a point on a circle with radius 3. Angle is pi over 3. C is a point of 4, 0, right? With a radius of 4 and the angle 0. So write an expression of the area of region 1, region 2, and region 3. And I show you the area is half of integration sine lower limit, upper limit, r squared d theta. Right? So let's see region 2. Region 2 is in between of F and G. F is solid, G is this. Right? So the R is just F minus G. That's it. Just R just F minus G. So we'll have a half. Then, oh, what about the lower limit? Lower limit is B pi over 3. Upper limit A pi over 2. So we'll have a half integration sine, lower limit pi over 3, upper limit pi over 2, and R squared d theta, right? It's R squared. Is it R squared? Yes, it's R squared. Well, what's R? R, we see we have to subtract G from F, right? R equals to F minus G. Region 3, we have to split into 2. We have to split into 2. So 1 goes from 0 up to pi over 3, half, of course, half of integration sine, lower limit is 0, upper limit is pi over 3. Well, what's R? R is F, right? F squared. And what about region 1? Region 1, a half integration sine, lower limit 0, upper limit pi over 3. Well, the upper one, what's R? R equals to G minus F, right? G minus F parentheses square. Anyone has any questions? Okay. Series of convergence. Okay, we have learned divergence test, ratio test, nth term test, root test, limit comparison test, the integral test. So consider this series. One of the five series convergence tests, identify 2 tests which will be inclusive and will not provide information about whether the series converges or diverges. Show your work. Well, let's see the divergence test. Divergence test is saying if limit of nth term goes to 0, right, then the series converge. Hold on. If the limit of the nth term does not go to 0, right, so that means the series diverges. If we do divergence test, so to take a limit of that equals the limit of the leading term in the numerator divided by the leading term in the denominator. Leading term in the numerator will get an n cubed term, right? We get a n cubed. Leading term in the denominator will get n to the 8th square root, which is n raised by 4. So we basically get, oh, that does go to 0. So that goes to 0, right? That goes to 0. We cannot make any, so this is inconclusive. If it doesn't go to 0, we will see this diverges. But because it goes to 0, we cannot make any conclusion by divergence test. Oh, you're right. You're right. They did not list the divergence. 1, 2, 3, 4, 5. Right. Okay, so we don't need to talk about that. We don't need to talk about that. So nth term test. Does nth term test work? Nth term means we can raise this to square, right? So if we raise this to square, nth term, we reach to square the numerator, we get 2n raised by 6. The denominator, we get n raised by 8. Then we'll take a limit of the nth term. Nth term test. What's the nth term test? Limit of an goes to 0. Nth term test. Okay, let's keep going. I don't remember what's the nth term test. Maybe called different names. Ratio test. Does ratio test work? Ratio test will be inconclusive, right? Because ratio test is saying doing n plus 1 term divided by n term. We will get ourselves into trouble, right? So ratio test won't work. What about root test? Root test won't work either, right? If we take a root of this, maybe by cube, it won't work either. So those two, so what does it say? Identify two will be inconclusive. So those two inconclusive, right? By ratio test, by root test, inconclusive already. What about limit comparison test? Limit comparison test should work, right? Which means we want to compare with an cubed divided by n raised by 4, right? So we want bn to be an cubed divided by n raised by 4, right? If we take a limit, if we take the, if we take a ratio of an with bn, take a limit, we should get 1. When we get 1, the limit comparison test says, if we get a finite number, whatever one sequence does, the other sequence follow. So what's bn? So what can we conclude with bn? Oh, that diverges, right? That's a over n. That's a times 1 over n. A times 1 over n. What kind of a series is 1 over n? Harmonic series. Harmonic series diverges, right? So this one can be done by limit comparison test to show it diverges. What about okay, of the 5 series, identify 2 inconclusive and will not provide information about whether the series converges or diverges. Your work. Oh, we don't need to show a convergence, right? Okay, use the show by root test, by ratio test and root test, right? If you take a root, you could take a root of cube. Where does that take you, right? You won't be able to make any conclusion. Also by ratio test. Ratio test, you take an n plus 1 term, you plug in n plus 1 for the n, you won't be able to make any conclusion either. Okay, it does say identify one test, so use a limit comparison test, right? That one works. Okay, any other questions for this series convergence? I think I'll also upload something for you to study. All right, power series. F of x and all its derivatives exist at x equals 5. F of 5 equals 8. F prime of x equals to 1 over f of x squared for all x. Where is the question? What's the question for this one? Suppose f of x has the following property, 3 properties, then what? Oh, okay, maybe for the following use, let's see. Let's see this one. This one we have this power series given. Find a series expansion for this. All right. Excuse me. So what do we do with this? So the key for this one is the integration sign and the summation sign interchangeably. Thank you, Damon. Okay, the key, oops. So the key for this one, so we just plug in f of x. When we plug in f of x with the summation, right, the power series summation, we just get x cubed times this summation. Then we can put x cubed in. So this 2 raised by n, 2 raised by n can be combined, can multiply 3 over 5 raised by n. So 2 raised by n times 3 over 5 raised by n, we would get 6 over 5 raised by n. So get x raised by n. Then x3 times x raised by n, we get x raised by n plus 3, right? Then integrate that. So we have x raised by n plus 3. Integrate that. That's just x raised by x plus 4 divided by x plus 4. Right? So the sign looks scary, but it's easy. Do I make sense? So summation sign, I've used s. So x cubed multiplied by f of x. So in the end, you just get a summation sign and 6 over 5 raised by n, because you can combine 2 raised by n by 3 raised by n. That's just 3 raised by n times 2 raised by n. That's just 6 raised by n. Then x raised by n times x3. That's x raised by n plus 3. When we integrate x raised by n plus 3, we get x raised by n plus 4 divided by n plus 4. That's it. With a summation sign, all right, with summation sign. So that's an interpretation or a series expansion for this. If possible, use a series to approximate, or you just approximate, right? You just put it in summation sign from 0 to 2, right? You just plug in n equals 0, n equals 1, n equals 2 to approximate. Anyone has any questions? Okay, let's do last one. So we have f of x, again, we have this, 2 raised by n factorial x minus 7 raised by n. Power series, right? A power series. So we want to determine f of 6.9 to within 0.0001. So 4 decimal places. It will be necessary to add the first. How many terms? Well, let's see, 6.1 minus 7, that's negative 0.1. Okay. Well, negative 0.1 raised by 0 would be 1, raised by 1 would be negative 0.1, raised by 2 would be 0.01, raised by 3, negative 0.0001, raised by 4, 0.0001, probably by 4, right? But because we have plus minus, right, you just calculate the 4 terms to see if you get, within 0.001. At most 5 terms. If it doesn't work because we have plus or minus, sometimes they cancel out each other. But I would guess this at most 5 terms. It should be within first 5 terms. All right. Most likely within, 5 terms. So then you just give the value f of 6.9, approximate value. All right. It's not so bad. Okay, so what do you think? How do you feel about this? It's not so bad. Okay, I guess, oh, okay. It should be similar or easier, I think. But I don't know. I don't have a copy of the final exam yet, so I shouldn't say anything. But again, you know, if they have some surprising, we will see. Will it be the same amount of questions? Oh, should be more questions, I think. Should be more questions, right? This is not enough questions for final. I think, I don't know. It might be, that might be nice, you know, give only this couple questions. But, you know, study your homework. Yeah, all right. Just that you have a, you know, little over than 1 week to do that. Study your homework, you know, master the material. As long as I have the room information, I'll post it on Blackboard, all right? If some of you cannot take the final, let me know. I will give you incomplete so you can take final next semester. Okay, any other questions? All right, I guess I'll see everybody on 24th then. Thank you, thank you. If you haven't finished your homework yet, make up your homework. It's also good for review, all right? Okay, thank you. Have a good night. Have a good weekend. We don't have class on Tuesday, Zachariah. It's readings week. But if you have any questions, send me email, all right? Yeah, I will post the room on Blackboard. James, I will post the room on Blackboard, all right? Okay, thank you. Yes, it's the 24th, May 24th from 6 to 8. Just we don't know the room yet. That's the only thing we do not know. Okay, good night.